Hey everyone, today we are dealing with the number system, but in particular the rational expressions and numbers and all of that stuff. Alright, announcements. Just remember, on October 2nd and 3rd, we're going to be doing the practice ACT, and we're going to do that immediately after your last quiz. Don't forget you had two more quizzes. You're going to have a quiz next week, and then you're gonna have one after that. Those quizzes are small, so they're not gonna take the whole class period. It is essential for you to demonstrate the skill that is needed. My biggest concern with many of you guys is that you're not here for the right reasons. You're not here to really get the education. You're here for anything else but. And that's really, really sad. I hope that we could get a chance to turn this around. But anyway, discussing the ACT. Out of the 60 questions that are asked of you, to get a pass in the ACT score, you must get 30 out of 60 correct, which gives you a score of 18. If you score 36 questions correct, you'll get a 21. And that 21 could be very beneficial for you. Having the 18 alone in mathematics would get you excluded from all tests and quizzes. Scoring at 21 or above would result in no quizzes, no homework, no test. Except for, of course, you gotta take care of ANA, which you are held responsible for. A good ACT score from this is going to be the last grade boost that I give. So if you want that boost, you may want to do right. You will have a unit test on October 10th to the 12th. You will have heavier workloads. I may say, hey, for homework, there's no Kahoots. I need for you to do everything by hand. Parent contact. I've been calling parents, been notifying them about where you stand academically. Best scores on your quiz. When you guys did the quiz for me, you took 2 parts, part one, part two. Whoever was your highest score is the one that is recorded in the grade book. Reminders. If you have missed my quiz from checkout for any other reason, you must make that up by appointment. So that means that you're not going to take the quiz when I'm teaching you. No. You're going to take the quiz either second block, A day, fourth block, B day. I need for you guys to pay very close attention to what's going on. In this lesson, we're going to discuss the number system a bit, perform basic operational rational functions, solve equations, and that's how we're going to do Kahoot. There's more something that I do in the class for you guys to go look at. Our number system. So I'm going to go through these. Pay close attention. Alright, so the natural number, which we use in the mathematical word for n represents a natural number. These are those numbers that you have been dealing with since you was a kid. 1, 2, 3, 4, 5, 6, 7, 8. I don't want to do no work. You know, those are considered natural numbers because they just 1, 2, 3, 4, or you call them just whole numbers. But remember, because you are in high school, the term whole number does no longer work. So you gotta keep that in mind. Alright? Integers. These are those things that you was introduced in middle school. So that Z stands for integer. So positive and negative numbers. You've been dealing with those since then. Right? Rational numbers. Okay, so listen up on this. This is something that you gotta be pay close attention to. Rational numbers are understood to be what you call a fraction, like 5/6. And again, I'm writing this with a mouse, so my bad. 11/12. Those are all rational numbers. We no longer consider those to be fractions. So we no longer going to use the word fraction. We're going to use rational numbers. A rational number is just two integers. And what I mean by integers, any integers you want to be. So when I use A and B letters, they're just saying any number you want it to be. It could be 5/6, a gazillion over a gazillion, anything like that. So when you see this backwards E, that's just saying A and B are integers. That's all this is saying. A and B are integers. And you see this, somewhat of a have or an elbow triangle. That's the mathematical symbol for and. And B cannot equal 0. So let me explain this in detail. So 5/6, we know that to be a fraction. But can we divide 5 into 0? 5 divided by 0. If you put this in the calculator, which I urge you guys to do, you will receive an error message. That's an error message, meaning that it's not allowed. So why don't you go on your calculator, go 11 divided by 0, 22 divided by 0, and see that you get the same thing, an error message. Alright? Real numbers are numbers that you see. So real numbers are natural numbers. Natural numbers are real numbers. Integers are also real numbers. Rational numbers are also real numbers. However, complex numbers are not real because you have an imaginary number, which is I. And we know I comes from some negative number, which we know can never happen. If we have a negative number, we have to take the negative out, write it as I, with that looks like a backwards J, and then square root n. Alright? So, just a reminder, factoring is going on. So through this video, this is what I want you to do because this is mainly old stuff that you know how to do, which that's what math is about, is using old stuff that you have already learned to do the new stuff. So what I want you to do is work with the vids. So here's what's going on. When you are working the problems with the video, you get better understanding of it. Now you should sit here and just, okay, I'm gonna play a video in the background and do 10, 20, 30, 40, 50 things. It's not gonna work like that. You have to work the problems with the video. These are, you know, because that's how you get better. Practice makes perfect. So that means you work the same problem over and over and over again. You may have a better understanding of it. So let's do it. So let's factor this. Before we continue, what is this? What type of polynomial is this? This is a binomial, and we understand this because you have two terms, negative 4m and 4m and negative 25. And I know 4 is a perfect square of 2 because 2 times 2 gives you 4. I know that 25 is a perfect square of 5. Now, because it's a binomial with a perfect square, you have to write your factors like this, which is going to be 2m minus 5 and 2m plus 5. Now, I wrote this problem for you, but ask yourself a question. How do I how does this become that? Remember how we did our following methods? I need for you to double check that, and you're going to do that on your own. This problem, this is what I want you to do. I want you to pause the video at this moment and do the problem yourself. So, do the problem yourself and pause the video. And once you did all the stuff, then play the video and see what you did to determine mastery. Alright. Did you check your work? Did you do the correct techniques? Let's find out. Did you realize that these are four terms, and because they are four terms, you could group them in pairs? Did you, when you group the first pair, you realize that the greatest common factor of this was going to be 3p squared? And from the inside of this, you got 4p minus 7. If that's what you did when you did your first factor group, which is here, excellent work. Did you factor the second grouping like this? And did you realize that the greatest common factor of this right here, this second grouping, was going to be 7, 4p in the inside minus 7. Did you, when you factor this, realize that this has to match here and here? Did you, for your last step, group your outer terms together as 3p squared minus 7, plus 7? Or did you group your like factors here? which is 4p minus 7. If you did all of that, good job. You're good to go. All right. I need for you to pause this video again and try doing it yourself. All right. Did you realize the first step that you have to do is multiply 3 and 4? And did you get n squared when you rewrite minus 8n plus 12? Did you realize that the two products multiplied gives you 12 is negative 6 and negative 2? Did you also realize that negative 6 plus a negative 2 gives me a negative 8? If you realize that, you halfway to go. Good job. Did you get n minus 6, n minus 2? Did you realize that, hey, that's not the final answer, but you realize that you got to divide by the 3? 6 divided by 3. They give you an integer, right? So 6 divided by 3 gives me 2. Did you realize that when you divide 2 into 3, it doesn't give you an integer? We gotta be careful with our language. And did you swing that 3 to the front and left the 2 in the back? If you did all of this, good job. You are awesome, you are talented, and you got it going on. Oh, that 3 looks sloppy, doesn't it? You're like, what is that? Okay, I can rewrite that 3. Again, I'm doing this on a keyboard and mouse. I don't have my pen with me, so just be glad that I was able to do that. I could rewrite my ends too. For those who's like, what letter is that? All I'm doing is just rewriting the ends, so that'd be cool. Alright, moving along. Alright, you go ahead and factor this. You do it. And don't forget to pause that video. You do this. The only way you're going to get better with math is doing it yourself and comparing it to my work. Alright, did you? I'm not going to go through the steps because by now you should be able to do this step by step. So I'm just going to give you the answer to this. I need for you to take the answer you see and work your way backwards. So if you need to go from here to here or here to here, I want to make sure that you know how to do this yourself because my job as your teacher is not to sit here and work every single problem out step by step, step by step. That would not happen. Right, rational functions. Let's get to it. So, all I'm doing is going through the Eureka lessons. I'm not going to bit by bit, step by step. No, won't do that. So, you guys, if you factored and you understand the factor techniques we did previously, if not, please go back and practice and look at those problems we just did. And if you also remember that all we trying to do is divide and where P and Q are integers, but we do know that Q by not equal 0 is going to make it undefined. So if we got this principle of the factoring, we good. So I'm going to erase. If I'm going too fast, please, replay the video part. Now, with that being said, let me go ahead and get these details. So we know which ones rational numbers, which ones are not. So remember, rational numbers can't have nothing in the denominator. And also, they gotta be real numbers. So I'll let you figure out why that is. I'm gonna keep going. So here, Eureka writes it funny about the definition of a rational number. The only thing you gotta know is a rational number is a fraction, which we don't use that word, but it's a fraction, whereas Q cannot equal 0. That's all you gotta know. Your denominator cannot equal 0. And don't use the word fraction, use rational number. Alright, so look. You got a thing that looks like this. So this is it's not hard lessons, factoring things and canceling things out. So look, just start factoring the numerator first. When we factor the numerator and the denominator, this is what we get. Because we know that when we factor this trinomial, those are my factors that I get. And then here with this binomial, I factor the greatest common factor. Now I'm not gonna go through this trinomial stuff because you guys should know how to factor a trinomial. You know that part. If you stuck with that, please practice the trinomial stuff that we did earlier. What's in the denominator? That's by the greatest common factor. So I'm not going to talk about that either. But that's our final answer right there. And again, if you are lost by this, all this is factor a trinomial and factor a binomial by the greatest common factor. So the denominator was just GCF, and then this in the numerator was just basic trinomial stuff. I went over these steps for the trinomial earlier, so look at that part again if you're struggling. And from there, after you group, cancel things that are alike. You're left with just that. And then remember that when you have a rational expression, your denominator cannot equal 0. It's not allowed to. So what I'm asking you to do When it comes to this, what's going to make this undefined? Meaning that what's going to turn this into 0? So, if you say x equals 0, 5 times 0 and 0 minus 3, you realize your answer is going to be negative 3 divided by 0, which we know cannot happen. So therefore, we say our final answer is going to be x cannot equal to 0, because if it does, it becomes undefined. And that's what we wanted to do. Here, I'm going to do this factoring for you. So here, what you see is a trinomial and something that's already factored. So let's do the numerator part. Well, I'm not going to tell you, step by step how to do it, but what you should have gotten n plus 1 and n plus 5. Because remember here, you gotta figure out what two numbers multiplied gives you 5, but when you add those same two numbers gives you 6, which is 1 and 5. Alright, and then here you got n plus 1 in the denominator. Now, you got something that could cancel out, something that could disappear. So listen up. When you have a pair like factors, oh, that's a good question. So I was asked, why don't you not factor n plus 1? Because n plus 1 is already factored out. There's nothing that you could pull out other than a 1. And if you do that, it's still going to be n plus 1. So let's do it. So after you factor the numerator and the denominator, you're looking for things that are like, you looking for them in pairs. So I have a pair of n plus 1. So anytime you have a pair of a factor, you could cancel those out and it'd be n plus 5. That's what I left with. And I do not have anything to make that undefined. If I plug in n equals 0, it's going to be just 5 by itself. Alright, so this is what I want you to do. I want you to try to factor this out on your own. Pause the video and try it out on your own. Alright, so let's compare our notes. Did you, in your numerator, got factors of a plus 1, a plus 4? If you did that, great job. Okay, so in your denominator, did you factor a plus 4 and a plus 5? Did you cancel the a plus 4s because they are a pair, and we're left with a plus 1 over a plus 5? If you did that, good job, good job, good job. You are awesome. You're smart. You got it going on. You're the smartest kid in class. Now, with that being said, what's going to make a become, your denominator becomes undefined? What a cannot be? A cannot be negative 5 because if I got negative 5 plus 1 and negative 5 plus 5, that's going to become 0 in your denominator. It'll become negative 4. So you know you cannot have 0 in the denominator. So you try this one out on your own. Guess I can help you out with the numerator. So your numerator, when it says 3 minus x, you just got to rewrite it and say negative x plus 3. And then after that, take care of it. Because you realize that x squared minus 9 is going to be x plus 3. And wait for you guys to finish that up. So, I'm going to move on. So, I want you to go to decimals and try this out. This is what's going to save a lot of you, alright? So, put in decimals. First thing you're going to do, of course, get to the keyboard. Once you go to the keyboard, press the division key. That division key is going to give you this. From there, this is what I need for you to type in verbatim. 3 minus x over x squared minus 9. And once you put that in, your graph looks something like this. So you'll realize that rational functions are quite different from polynomial functions. So you have to ask yourself, when you look at this graph, where on this graph where the line is not going through at what particular value. So that means if I draw a vertical line, if the graph does not touch the vertical line, that's what I'm looking for. So I draw my first vertical line. It touches at negative 8. It touches at negative 7. It touches negative 6, negative 5, negative 4, negative 2, negative 1, 0, but it does not touch at negative 3. So what they're saying is that if x becomes negative 3 in your denominator, that's going to be a problem. Because you can't have that problem. So the graph does not touch us at negative 3. Now, I'm going to need for you to research to find the difference between polynomial and rational graphs. Alright, multiply and divide. I'm going to leave it from there.